Gosh, seriously, whiners, suck it up. Welcome to college, dear. Right, Gertie? There we go. Okay, so let's graph y equals e to the x and y equals log base c of x. So remember, e is approximately what? 2.7. Good. Dude, because I've said it like 100 times. There we go. Okay, so. Okay, didn't work. Nice try. Got to pick your moments, Gertie. Come on now. All right, so e to the x. So let's graph that. So we're at -1 and 1 over e, right? Which is a little less than a half, give or take. We're at 0 and we're at 1 and e, which is 2.7-ish, about right there. Okay, there's e to the x right there. Okay, and we just labeled those 3 points, right? -1 and 1 over e, 0 and 1, and 1 and e. Okay? Now let's do the logarithm. Oh, sorry. What's the domain and range of that exponential? Domain?
0 to...
Domain? All real numbers, right? Look at the graph. Domain is all real numbers, right? And what's the range? Now say it, Josh. 0 to infinity. Good. Where's my asymptote? Y equals 0. Okay, name that function. Exponential base e. Good. Okay, now let's graph logarithms. So log base e. So our bases are the same. So what do we do with our points? We switch them, right? So instead of -1 and 1 over e, we have 1 over e and -1. Instead of 0 and 1, we have 1 and 0. Instead of 1 and e, we have e and 1, which is 2.7 and 1, roughly right there.
Can I ask a dumb question?
You always do. No, I'm kidding. Yes, Gertie, you can. Because that's what the log is. Exponentials and logarithms of the same base are inverses of each other. So that's why I say, if you're struggling graphing logarithms, graph the exponential, and then just flip your x and y. Because you guys are good at the exponential, shifting it and stretching it and flipping it and all that stuff, right? So if you're struggling with the logarithms, graph the exponential and then just switch x and y. You're gold.
So who comes up with the word log? Okay.
Couldn't tell you, Emma. It's one of the great mysteries.
Same person that came up
Some
with
really drunk mathematician somewhere back in the ages. I don't know.
I'm gonna call this a logarithm.
What? That is so stupid that'll never catch on. Oh, wait. Okay, so now 2 exponentials are used more than the others, and we kind of touched on this a little bit before. All right. So the 2 exponentials that we use are base 10 and base e. And it's the same thing with logarithms. In fact, those are the only 2 logarithms that you have buttons on your calculator for. Okay? So if you look at your calculator, if you don't have one, come grab one of my yellow ones. All right?
I have a pink one.
So what is the inverse of exponential base e? We'll just kind of keep going here a little bit. What's the inverse of exponential base e? Log base e. What is the inverse of inverse exponential base 10? Log base 10. Correct. Okay. Now, because these logs are used so often, we give them special names and we write their logarithms in a slightly different way. So log base e is what we call the natural log because it occurs in nature so much. And it's written lnx. Why they write natural log is lnx, I have no idea. Again, refer back to our drunk mathematician of the ages, right? Okay. So, and it is said lnx. So when you hear me say lnx, you know I mean log base e, or the natural log, okay? And it is the inverse of e to the x. It means log base e, correct. ln is natural log. Log de natural. Maybe that's how. Maybe some French guy did it. I don't know. Well, hey, if someone's going to be drunk, it's probably someone that's French, right? No, I'm kidding. I hear they make really good wine in France. That's all I'm going to say. Because I'm going to get myself in trouble and get fired here. No, I'm kidding. Okay? All right, and the next one which we've already talked about is our common log, which is log base 10. Okay? Again, because it's the basis of our number system, okay, the common log. And again, all you just say is log of x. If you say log of x, it's assumed base 10, okay? All right, and again, the nice thing about them, they're the only one that appear on scientific calculators. So look at your calculators, you're gonna have a log button, and you're gonna have an ln button. Now, if you look at the second function of each of those buttons, what's the second function of log x? Oh, 10 to the x. What's the second function of ln? E to the x. So their inverses are built in for you right there as well. Okay? Not too shabby, huh? Okay, so we just answered those next questions, right? The second function, so the other function, ln, does e to the x. And the log button will do 10 to the x. Okay? So how are these two functions related? They are inverses. Yes! Nicely done. I'm not going to write that down, but you got it. Okay? All right, now we're going to use some calculator to crank out some approximations. Always understand, okay? On MathXL and on exams and things like that, if it asks for a decimal approximation, then you're okay. Pay attention to how many places it'll say. It'll just say, like, you know, give a decimal approximation to 3 decimal points, or 3 places after the decimal point, okay, or something like that, okay? So pay attention, all right? So what's the log of 5?
0.6, 0.7.
Okay, let's go 3 after.
Looks like 6989.
0.699, okay.
Okay.
That would be 3, right? Okay, what about ln 15?
2.708.
Say again?
2.708.
2.708, okay. What about log of 100?
2.
Right, because 10 squared is 100. Yeah, you got it. Okay, log of negative 5 over 6. Without even punching a number in, what are you going to get?
605.
Eh,
That was a guess.
really? Can you take the log of negative numbers?
No!
Okay, try it.
Domain error.
There you go, domain error, because negative 5 over 6 is not in the domain of logarithms.
You wrong pants.
Okay, ln of 0.23.
Negative 1.4696.
We can use this on the test.
Calculators?
Yeah.
For some of it, yeah. Okay, the ln of 123,456.
Well, this is a tough one. 7236401.
Sweet.
10 to the
All right, now let's do the second functions of those. So 10 to the 2.1.
125.89.
Do that second log, and then type in 2.1. Okay, you got that? Emma, we got it?
Yep.
Oh, I just did the wrong thing.
What?
10,
Sure, Gertie. Okay, what's e to the 4th?
2.74.
2.9.
What is it? What'd you say, Josh? 7.4?
53 point.
I got 54. I got 54.59.
On e to the 4th? Yeah, I was gonna say, oh, you were just telling me what e was. Freak, Josh can't do that to me, dude. 2.78, by the way. So again, what was it? I'm sorry.
54.598.
Yeah.
Okay, 10 to the negative 0.25.
0.562.
Yep, you can. 0.562. Okay, e to the e.
Where's this normally?
Ju- Okay, so here's how you can handle that on those calculators. Go e to the, and then e to the, and then stick a 1 in there, like e to the first. So e to the first.
15.154.
That sounds about right.
That was fun. Can we just do those for the rest of the class?
Yeah, we wish, right?
No.
All right, so now calculators are nice if and logarithms are really simple if we have log base E or log base 10, correct? Because we got buttons for that. But what if it's not log base E or 10? Bit of a problem, right? Because we don't have calculator buttons for it. So we introduce to you the change of base formula, okay? And it basically is this. If I have log some base B of M, then that is simply equal to the ln M over ln B, or it's also equal to log of M over log of B. And that log is base what? 10. So basically, you can change it to whatever base you want to, and we'll always change it to E or 10 because those are the buttons we have, right?
Yeah.
So, let me show you how this works. It's actually really simple. So log base 4 of 21. So I want half of you to do this. I want half of you to do, so for the change of base formula, it's ln 21 over ln 4. And the other half, it's log of 21 over log of 4. So half of you do ln 21 over ln 4, and the other half do log of 21 over log of 4. Okay? What's ln 21 over ln 4? Somebody have that?
2.196.
2.196.
Wait, I want to figure it out too.
Okay, what's log of 21 over log of 4?
2.1.
Wow, 2.196, I'll be darned.
Wait, do you do
Exactly
that
the same.
fraction or as a division?
I did it as a fraction, not like that.
Yeah, so I do too.
Yeah, go log 21, close your parenthesis, divide by log of
Oh, you
4.
have to use parentheses?
You gotta close that parenthesis. When you hit the log button, it'll almost always give you parenthesis, correct?
Yeah.
You gotta close it,
So log,
okay? All right, so log base 15 of 225. So again, ln 225 over ln 15, or log 225 over log 15, and we get,
I love you.
2.
because 15 squared is 225, right?
now I have
But
an
if-
overflow, Henry.
But if you don't know that, close your parentheses.
It's like an equal sign or is it like,
Mm-hmm.
Okay.
which one?
What is wrong with this?
Let me see.
It did not count.
Okay, so either do ln top and bottom or log top and bottom, but don't do ln top and log bottom or log top ln bottom. That's bad.
Bikini bottom and
Okay.
top bottom.
Gertie, stop talking.
I'm sorry, I was trying to help him remember.
Yeah, okay, thank you. Maybe not. Okay, so log base 8 of 7? All right, Gertie, now you can talk again. So what is it, log of?
Log of 7 over log of 8.
Good, log of 7 over log of 8. Or ln 7 over ln 8. Okay.
How come we don't just take a log 8 and then 7? What is like
Because that's not how it works.
Okay, I'm sorry.
And we don't have a base 7 button on our calculator, so we have to use a change of base formula.
So it's not gonna, that won't calculate into a number?
Yeah, well, sure will. Let's just do ln 7 divided by ln 8. Or log 7 divided by log 8, doesn't matter.
Log six,
What is it?
0.93578 for log of.
0.93, we'll just stop there for now. Okay, log base 0.6 of 60, what do? Tell me what you're gonna type in. Log of 60 over log of 0.6. And we get,
Negative 8.0151511.
okay, we'll just leave it at -8. Thank you, Professor. All right, so again, calculators are nice, but we have to be able to graph the common and natural logs with their inverses. So let's chat. So we've already done the boxes, right? We're reviewing again. Now, the reason this is coming up again right now, because at Itinerus, these are 2 different days. So we're reviewing this, but here we're cramming into one because that's how we roll here. Because we only meet every other day here at Itinerus, we met every day, so. All right, so again, we know our exponential functions, and now this being the 3rd time you've seen that, it's probably kind of a big deal, right? We probably need to make sure we understand our exponentials. Okay, so logarithm. Again, it's called log base A. Base must be positive number other than 1. Domain is
0 to infinity.
0 to infinity, and the range is
Infinity to infinity.
negative infinity to infinity. And it has what kind of asymptote? Vertical asymptote. at x equals 0. Good. X equals 0. Good, good, good. Okay. Yeah, this, I told you this lesson is pretty easy. That's why I love Brittany, right? Calls it like it is. Okay, so 10 to the x and log of x, we've already done this, right? Let's review though. It's always a good review. Okay, so 10 to the x. So we go to negative 1 and 1/10. 0 and 1 and 10. So that is really steep, right? The bigger that base is, the steeper it gets.
Just imagine that roller coaster hill.
Okay, logarithm. Okay, so where's my first point? Yeah, well, other way. 1/10 and negative 1, right? I know that's what you meant. 1/10 and negative 1. Where else?
0, 1.
That would be the blue one. 1 and 0. And 10 and 1. Thank you. That would be a really lame roller coaster. That's pretty flat. Until you fell straight down. Then you would wet yourself at that point, right? So. Okay, so e to the x plus 1. So what does that plus 1 do?
It
Shifts it
to the left.
up. Shifts it up 1. Okay, if that's what you meant, then you are right, Gertie. Whew, okay. So instead of negative 1 and 1 over e, I'm going to write these points down. So we normally have negative 1 and 1 over e, right? It's negative 1 and 1 over e plus 1.
How do you plot an E?
It's 2.7-ish.
Oh, that's right.
All right, so now we're at negative 1 and just a little less than 1.5. Okay, now instead of 0 and 1, we're at 0 and 1 plus 1, or 0 and 2, correct. Instead of 1 and e, we're at 1 and e plus 1.
Plus 1.
So so we're now at 3.7, and there's our graph. Tell me about asymptote, people.
X equals 1, y equals 1.
Excellent, Britt. Asymptote at y equals 1. Domain and range, did that change at all?
No.
You changed your range, did not your domain, but so you're right, Gertie, did not change your domain at all.
That's what I meant.
I knew that. You're welcome for bailing you out and trying to make you look smart. Okay? What about the range?
It's 1 to infinity.
From 1 to infinity. Good. Okay, so our range is from 1 to, is 1 included?
No.
It is not. Excellent. Okay, now let's look at part B. So what is that negative out front going to do?
Flip it.
Flip it over. It's going to change our y, change the signs of our y's, correct? And what's that minus 2 going to do? Shift it down 2, okay?
Is it gonna flip it over the x-axis?
Correct. X-axis. That's why it's changing our y values, okay? So again, so our normal points, let's start them, okay? Now this is an exponential, so we got negative 1 and 1 over e, 0 and 1 and 1 and e, correct? That's where we start. All right, so now the negative here is going to change all these signs. And then the minus 2, we're going to take all those signs and subtract 2 from them. Correct?
Correct.
All right, so now we're at negative 1 and negative 1/2 minus 2. Roughly negative 1/2. Okay, we're at 0 and
Negative 3.
negative 3. Oh, I missed on that first point completely. That, yeah, that should be like negative 3.5-ish. So let me give you that point there, and then our first one's right here. And then we're at 1 and negative e. Wait. No, I was right. Gosh dang you guys. Yeah, I was right on that first one. Okay, let's do this. Hang on. Stop.
Did you just ask him if you wanted your autograph?
Okay, so we know, and without plotting all the points, the original is going to look roughly like this, correct?
Correct.
Okay, so if I flip it over the x-axis, all right, now it's going to look like this. right? And then I'm going to shift it down 2. So now it's gonna look like this.
So could you just take the,
So now it's gonna look something like that, roughly. Black one's your final.
Okay, so grab the original. Sure.
Okay, so again, so let's do points. So for our blue one, the points are -1 and 1 over E, 0 and 1, and 1 and E, correct?
make them negative?
The red one makes them all negative. So I actually sucked on my red graph, to be completely honest.
Yeah, I'm kind of wondering why it was on.
Yeah, be quiet.
Just saying.
You could put it in your scrapbook.
Yeah, so, there we go. Gertie?
It's on Kissy Lips too.
Oh my gosh.
Yeah, what?
Okay, so it's right there. All right, okay, so there's that one. Britt, we happy now?
Yep.
Ugh. And then I messed the black one up too, because I wasn't exact, and Brittany's gonna call me on it, so let's go make it exact. Okay, so we shift it down 2, so we're shifting it down 2.
I'm a little OCD.
Point for the first one.
For the blue one?
No, for like the first point of the black one.
Okay, so it's -1 and -1 over E minus 2.
What is that like?
Negative.
So -1 over E is roughly -1/2, so -2.5,
Negative 2.
give or take.
Give or take.
So when we're putting into the calculator, can we just do 1 over 2.7?
Yes, yeah, just get a decimal for that, Emma. Get a decimal approximation for that. Because you know what, I'm not gonna get out my magic exponential graphing glasses and, you know, figure out if that point's exact or not, right? Roughly 1/2, and I'll be totally okay with that, okay?
We're in that
We're
range.
almost done.
I was bored with the voice box.
So we need to do the domain and range of that, of the black graph there, the black line. So what's the domain? What's the domain always?
All real numbers.
All real numbers on exponentials. What's my range?
Negative something, and then.
Negative other way, Josh, you're right, but you could say the smallest first. Negative infinity to -2. Good man. Good man. Okay? Okay, so what is this +1 gonna do? Shift my graph up. Okay, now, do you wanna start with the exponential first, or can we write our logarithm points? Okay, let's try. So we know now, but now we know our y values for our logarithms are what? Our y values are gonna be -1, 0, and 1. What are my x values gonna be? This is the original, so let me,
It's gonna be 1 over ln.
1 over e,
Wait,
1 and e, correct? Because it's natural log.
why are you using natural log?
Because it's ln, right? What's ln? ln is log base e. And you guys are kind of mean to each other. You know, I'm all trying to be nice, you guys are just, rawr. Okay, so there's our original.
You get irritable.
All right, so now what's this +1 gonna do? Shift everything up 1, correct? So we add 1 to what values?
To the y.
To the
Y.
y values. Okay, so now instead of 1 over e and -1, we have 1 over e and
0.
0. Good. So that puts us about right there. Instead of 0 and 1 and 0, we have 1 and 1. And instead of e and 1, we have e and 2. So there's our graph right there.
Why did you do it in log form? The chart, like you make the y's -1, 0, and 1, and not the x's.
Because it's logarithm and not exponentials. Logarithms are inverses of exponentials. So to do logarithm, we have to switch x and y.
Logarithm though, like the.
Okay, to finish part A, 6A off here, what's my domain and range? What's the domain, and it's the red one, that's the final one, so what's the domain?
The domain
Is 0 to infinity, what's the range? All real numbers, good. Vertical asymptote at?
x equals 0.
Jetto, correct. All right, so what's this 2 gonna do? The first 2, sorry, the 2 out front.
It's gonna, oh,
What's that one gonna do?
that's That's gonna expand
It's
it.
gonna stretch it, right? Good. And then what's this minus 2 here gonna do? Shift it
To the right.
to the right. Good, exactly, to the right. And what's this minus 2 gonna do? Shift it down. Okay, so again, let's draw our original points. Let's draw y equals ln x. So again, we've got 1 over e and negative 1, 0, no, 1, sorry, other way, 1 and 0, and e and negative 1. Okay. So there are our original points.
Why do we have two negative ones?
Yeah.
That shouldn't be a negative 1.
I'm glad Brittany showed us.
That should be a 1. Okay, so 1 over e and negative 1, so that puts us about there. 1 and 0, and e, 1, 2.7, and 1. So here's our original ln x graph. Okay? Now let's start messing around. So now, this 2 out front, again, like Josh said, it's going to stretch it, so we're going to times all of our y values by 2. Okay? So the black one then now, and these are all points, by the way, so now we're going to times it by 2, times it by 2, times it by 2. So now our new points are 1 over e and negative 2. So now we're right here. 1 and 0 stays the same. And e and 2. So now we're up here. So that's the effect that 2 out in front has. Okay. Now we're going to shift it. And we're going to shift it which way again? Right 2 and down 2. Okay, so here, for the black one, let's write our new points and see what they look like. So for the black one now, they're 1 over e and negative 2, 1 and 0, and e and 2. Okay? Are we all okay with that?
Yes.
All right, so now with blue, we're going to shift it. So we're going to add 2 to our x's and subtract 2 from our y's. So I'm just going to do this for our x's. We're going to go 2 plus here, 2 plus here, and 2 plus here, and then here I'm going to go minus 2, and minus 2. So and again, remember, this is from the black one, okay? So let's start with the lower point here. So I'm going to go to the right 2, so I'm at 1, 2, and I'm going to go down 2. 1, 2, I'm right here. Okay? Now I go to the middle one, to the 1, 0 point. So again, I'm going to go right 2, and down 2. Now I'm right here. And then I'm going to go to the top point here where I'm at E and 2. So I'm going to go again right 2 and down 2. And here's our graph.
That's a lot easier than like subtracting it and multiplying it.
Right. Yes?
I'm lost by the blue part. I get that you're adding and subtracting.
Right, so I'm going right 2, so I add 2 to my x's, and I'm going down 2, so I subtract 2 from my y's.
And we're starting
At the black one.
0.
So I started, okay, here, let me see if I can switch something here.
Rainbow.
Okay, so I started with this point right here, Mary.
Right.
Okay, and I shifted it right 2 and down 2. Then I went to this point right here, and I went right 2 and down 2. And then I went this point right here, and I went right 2 and down 2.
I'm just confused on the.
That doesn't look good. You can't even see that. I'm sorry.
No, I see what you're saying.
Right?
I'm confused on the bottom one. Yeah, no, yeah, the bottom blue point.
Okay. So I went, again, so I started, yeah. Let's go here. Thank you. No. Stop. Okay, so I started at this point right here, correct? And then I went right to, so I was at 1 over e, right? Or I was at about 1/2. So I went right 2 to 2.5, and then I went down 2 to negative 4. And that's where that point came out. Right? Because 2 plus 1/2 right here is 2.5, and negative 2 minus 2 is negative 4. So, and then there's my point. Light bulb, it just got brighter in this room.
Yeah.
Okay, so now, domain and range. What's my domain?
All real numbers.
Domain is x values.
0 to make,
If I didn't shift it, yes, it'd be 0 to infinity, but I shifted it. So what's my domain?
negative
Negative
2.
infinity to negative 2.
You guys are so close. Look at my graph, right?
It's infinity to
Where's my asymptote, people?
negative, it's 2
Negative,
to,
positive.
Say it, you're right, Josh.
2 to infinity.
Thank you. My domain is 2 to infinity. Because I shifted it right to, so it goes from 0 to infinity to 2 to infinity. And domain doesn't change. Domain is always all real numbers for logarithms, right?
So that number on the end doesn't matter for logarithms? Like that plus one in the first one and the negative?
Right, that doesn't change my domain. The only thing that changes my domain is when I shift it left and right. Now exponentials, that's completely different, right? It's the opposite, which would make sense, because they're inverses of each other. So when inverses, when I shift them up and down, that changes my domain of my exponentials. Logarithms, when I shift it left and right, that changes the domain of my logarithm. Okay. So negative 10 to the x, what does that negative do? Takes all my y values and changes their signs, right? So the original, again, we're going to graph the original, so we're at, now this is an exponential, it's not a logarithm. So my numbers over here are negative 1, 0, and 1. So negative 1 and, what's my y value?
10.
1 over 10, 0 and 1, and 1 and 10. There we go.
Then that just
So here's our points.
negative.
Okay, so there's the black one, the black graph. Now the blue graph, what does that negative out front do? Changes all the signs of my
Y.
y values. Bang, bang, bang. We're done. So now we're at negative 1 and negative 1/10, 0 and negative 1, and 1 and negative 10. So now my graph looks like this.
They're just inverses of each other.
Exactly. You just flip it over the x-axis, right? Domain and range of the blue one. Domain and range of the blue one.
Oh, it's infinite, negative.
Domain is
Negative infinity.
all real numbers, right? It's this way. It's all real numbers. What's my range? Negative infinity to 0. Good. Okay, now last one. Holy craziness, right? Okay, let's get our original points. So now this is a logarithm. So my y's are negative 1, 0, and 1, and my x's are,
And how do you know it's a logarithm?
because of the ln sitting right there, dude.
That makes a lot of sense.
That's a pretty good indicator it's a logarithm. Right? Okay, so now again with the original, so ln x, so x is 1 over e, 1 and e, right? That's the original. Let's plot those real quick. 1 over e and negative 1, 1 and 0, and e and 1.
So 1 over e is basically 1/2.
Correct.
Okay.
It's 1 over 2.7.
Well,
A little closer to 1/3 probably than 1/2, so however you want to deal with that, I don't care. All right, now, number out front, what's that going to do? That negative out front, sorry. Just change my y values, right? Change the sign of all my y values. So now this goes to +1, 0 stays the same, and negative 1 there. Okay, should we graph that real quick? Okay, let's plot the red one. So the red one's just this negative here. So we have 1 over e and positive 1, 1 and 0 still, and e and negative 1. So now it looks like this. Correct? We all okay with that? All right, now the blue one, we're going to finish it off. What does this minus sign do? That's not going to shift it. It's going to flip it again. But now over which axis? Over the y-axis. So if I flip it over the y-axis, I change the sign of my x values. Okay? So now instead of 1 over e, it's now negative 1 over e. Instead of 1, it's negative 1. And instead of e, it is negative e. So let's plot those points now. So now I'm at negative 1 over e and 1. I'm at negative 1 and 0. And I'm at negative e and negative 1. So now it looks like this. Okay. All right. A little hesitant to ask, but for the black one, domain and range. What's the domain of the black one?
All real numbers.
Domain This way, it goes from
Oh.
negative infinity to
Positive.
To
zero, right? Because it cranks on up.
Right.
What's my range? Negative infinity to infinity. Good. E squared, ask.
Why did you make the 1 over e negative 1 e? Why'd you make it negative?
Because of this sign right there.
I thought that shifted it to the right.
Nope, it shifts it if it's behind the x.
Is it like x equal?
So if it were like x minus 2, then I would shift it to the right 2. But if the negative's out front, then that changes it before you shift it. Okay? So whenever a negative's out in front of it, that's gonna be a flip thing.
So with that problem, you just make both sides negative?
Correct. Yep, exactly. Because the red circle flips it over the x-axis, the black circle flips it over the y-axis.
Last quarter, it's always super giddy.